Hi everyone, so we're going to keep going with our next lesson, graphing and using X and Y, doing graphing using X and Y intercepts, or exercise 4B in your textbook. So just a reminder of what we talked about last lesson. The X-intercept is where the graph cuts the X-axis, X-intercept, X-axis, and at this point Y equals 0. Also, y-intercept is very similar, where the graph cuts the y-axis, and at this point, this is where x equals to 0. And that is because when the other intercept is equal to 0, that means it's on our axis. It hasn't moved at all in either the horizontal or the vertical direction along the other axis. So you can find the intercepts in linear equations by substituting 0 into the equation for one variable to find the other one. Now, of course, there's two variables, so we actually need to do this twice each time, but it's a really simple process. And once you've got those two intercepts, we can draw them on our graph and easily plot a line through it. So it's a really good way to draw a linear equation. So let's have a go at that. So we're going to find the intercepts of the following equations and plot the graphs. So it doesn't matter which one you're going to do first. I'm just planning on doing the y-intercept first. So y-intercept, we find that when we let x equal 0, because that was part of our rule. That's where x equals 0. That will help us find the y-intercept. So we're going to substitute for 0 instead of x into our equation. So that will give us 4 times 0 minus 2y equals 8. 0 minus 2y equals 8. Negative 2y equals 8. Y is obviously, we need to divide both sides by negative 2 to get rid of that negative 2, so y equals negative 4. Now, obviously, you also don't need all of those steps if you're feeling very confident, but put them in if you need them. So it's best at this point to write our y-intercept as a coordinate. And remember, we said x equals to 0, so we put 0 in as our x-coordinate, and what we just found in as our y-coordinate. 0, negative 4 is our y-intercept. Now let's do exactly the same thing and find our x-intercept, but this time we're going to let y equal to 0. So if we do that and substitute into our equation, we'll have 4x minus 2 times 0 equals 8. 4x equals 8, and I'm going to do less steps in this one. Of course, we have to divide both sides by 4, so that's going to give us x equal to 2. So 2 and 0 is our coordinate here. And it also asks us to plot the graph, so let's do that. Now, it's best to find these coordinates before you draw your axis, because sometimes you need more negative axis and sometimes you need more positive axis. So in this case, I need positive x-axis and negative y-axis. So I'm going to draw my graph something like this. You, of course, are going to use a ruler, but as we know, it doesn't work brilliantly on the screen, so I'm not doing that. So y and x. 1, 2, 3, 4, and I need negative as well. Now, plot both of those points. So 0 and negative 4 is going to give us down there. 0, remember, always x first, then y. And 2 and 0 is going to give us this point here. And I only need 2 points to draw a line, so now I've got enough to draw my linear equation. So we draw our line directly through the points. Remember, it is really important to go further than the points. Put arrows on the end of your line. And the last thing you should be doing is writing our equation next to the line. Awesome. Okay, now let's have a go at another one. So this time we've got minus x plus 7y equals 21. Exactly the same thing we're going to do. So our y-intercept, we're going to let x equal to 0. And you really should say this each time because you're explaining what you're doing. So instead of instead of x in my equation, I'm going to put 0. So negative 0 plus 7y equals 21. Y equals 21 divided by 7, y equals 3. So 0, 3 is this coordinate. Our x-intercept, same as before, let y equal 0. So substitute that in, gives us negative x plus 7 times 0 equals 21. negative x equals 21. We need to divide both sides by negative 1, which means we have x equals negative 21. So our coordinate here is 21 and negative 21 and 0. Now, the other thing we have to do is plot this. Now I need lots of negative x-axis and I need positive y-axis. Now remember, when you're plotting on axes, the axes don't actually have to be to the same scale, as long as on both sides of the y and the x they're the same with each other. So I'm just going to go up in ones, 1, 2, 3, 4, 5, because I only actually need up to 3 to plot it. Now I'm going to go in the negative x direction in 5s, because otherwise I'm going to have a really big graph, which is also okay, but you've got to see the paper that you're working with. So, oops, that should be 25, of course. So as long as I kept going with 5s and 10s this way, and I kept going down this way into negative 1s, it's perfectly fine that I've got a different scale on both axes. So let's plot these. So 0 and 3, whoops, is going to be this mark up here, and negative 21 and 0 is going to be that way. So plot those points and draw this line. Now that is a terrible line, not at all straight. It's really important you use a ruler, because obviously I can't, and I've ended up with a line that's not super straight. So what you're going to do now is exercise 4B, questions 7 and 11, and I would really like it if you finish that to do extra question 10. Good practice for that. And of course the homework for next lesson is watch the lines with OneNote, intercept and gradient lesson screencast. There may be more than one for that lesson, and take notes getting ready for our next class. All right, thanks very much. See you then.